hard time containing my excitement right now because I just found out the protein I concentrated yesterday is active. So spin concentrators or centrifugal ultrafiltration devices. Basically, these things allow you to concentrate solutions containing a protein, which you might want to do if you are going to say you want to store the protein. It's better to do it at a higher concentration, or you need it at a higher concentration for your next purification step, such as a size exclusion chromatography. How these work is that they have a little bucket with a membrane. And this membrane, you choose a size. They have different molecular weight cutoffs we'll talk about, that you choose a size based on how big your protein is. Your protein cannot get through the membrane because you choose one whose holes your protein can't get through. Everything else, like all the little stuff and all the solvent and stuff, can. So what happens is that your protein's going to get stuck on here, but as you centrifuge it, so you stick it in here and it's going to spin and spin and spin, well, all of the spin force is going to pull the liquid through and any salts and small things that can get through, but your protein is going to stay in here. So your protein is going to end up getting concentrated because you're taking out everything out. You're taking out all like the liquid around it. And so these are really, really helpful, and we use them a lot, and I want to tell you more about them. So we have a bunch of different molecular weight cutoffs and different sizes. And so the size is going to depend on how much liquid you have, and the molecular weight cutoff is going to depend on the size of your protein. These membranes are what we call semi-permeable, which means that they can let some things through, but not others. So in this case, we choose a membrane that is permeable, so it lets through like waters and small salts and stuff, but it's impermeable to our protein, so our protein can't make it through. So all of that other stuff is going to get pulled through, where our protein is going to stay in here. And so the membrane is semi-permeable. It's impermeable to our protein because we've chosen a correct molecular weight cutoff, this MWCO. The molecular weight cutoff is basically telling you that if you had a perfectly globular protein of a specific weight, it would 90% or more of it would be retained, so it wouldn't get through. But you don't want to lose 10% of your protein, so you wouldn't want to choose a molecular weight cutoff that is the same as your protein. Additionally, molecular weight cutoff is telling you about like kind of like the size of the pores, the size of the holes in the membrane. But it's doing so in this kind of indirect way, because what it's telling you about is it's based on the molecular weight, which is like the mass of the protein, like how like heavy it is. And the pores don't care about that. The pores care about how big it is. So if you had a protein that was, you can have the same protein, like the same weight protein, so the same number of amino acids. It will actually the exact weight will depend on the type of amino acids, but typically there's about 10 amino acids per kilodalton. So if you had 1,000 amino acid protein, that would be about 100 kilodaltons. But you could have a really compact protein or a really loosey-goosey protein, all sorts of different things, and so they'll have different shapes, they'll have different sizes. They won't maybe act their weight. And so you need to be careful when we're talking about this molecular weight cutoff, which is one of the reasons why you want to use one that's at least half or less than your protein's molecular weight. So if you had one of those 1,000 kilodalton proteins, you would want to use if you had one of those 100 kilodalton proteins, you would want to use a 50 kilodalton membrane cutoff or less. So the membranes, they often come in like 150, 10, 3 is what we have. Really want a 20. I don't know if they make 20s, but I want one. So basically you choose the size that's less than half of your protein's molecular weight. So if your protein, so yesterday I was purifying a protein that was like 40 kilodaltons, and I had to use a 10 because I didn't have one that was like in between. At least I have to use the 3. And so the reason why you don't want to go too small down is because then it's going to take you forever to concentrate, because even though because although the little things can still get through, there's less, like, the pores are smaller that they're getting through, so it's going to take them longer to like kind of like bang into it right in the right direction and get it straight shot through. Because all of this is just happening because these molecules are just like moving all around, and if we're forcing them this way, but they have to actually like get into through the pore and not just like hit the mesh type of thing. And so you want to choose one that is less than half of your protein's molecular weight. Because so we talked in my post on like dialysis and stuff, we can talk about how we can have semi-permeable membranes that allow some things through. And if you allow in dialysis, what you do is you just allow diffusion to let things flow through, and just rely on diffusion to have things go either way. Here, we don't want things going either way. Here, we're actually going to be forcing it through this membrane, and we're providing this force that's going to drive it through this semi-permeable membrane. And so this can be various ways. There's some that are like vacuum, but these are spin concentrators. So here, the centrifuging is going to create the force that's going to drive things through. And when we use a force to drive things through a semi-permeable membrane, we call it ultrafiltration. If that was something that had always confused you, that's why.
Man, I keep thinking of things. The other thing I wanted to say was that if you might think, oh, why need size exclusion? I could just separate things with this molecular weight cutoff. It's not that clear cut. It's like an average type of thing. Plus, in order to actually be able to separate things with one of these, you need to have at least like a 10-fold, like a magnitude of difference between the weights between them. So you can separate maybe like your 100 kilodalton protein from your like tiny little salts, but you can't separate your 100 kilodalton protein from your 50 kilodalton protein, or even from your 20 kilodalton protein, even if you're using one of those 50 kilodalton molecular weight cutoffs. So yeah, so it doesn't work for that sort of thing, but you can use it for removing, sometimes you can use it for removing various dyes, various things that you might have in some sort of labeling reaction, all sorts of weird stuff.
These filters can also be used for like nucleic acids, so like DNA and RNA, especially like the little ones, or if you had a ton, you could use one of the bigger ones. These can also be used for desalting and buffer exchange as an alternative kind of to dialysis, except that it depends on like the volume and stuff too. But basically they're different, but both can be used for these things. With dialysis, you're basically sticking your protein in a little membrane sac, and so it's the same type of membrane where we have it semi-permeable, but here we're just like in a sac of liquid, and the molecules are flowing in and out, and so your protein is stuck inside, but all the salts and everything can flow out, and other buffer components can flow either direction, so you can use this to take the salt out if you have a buffer out here that's the same as in here but without the salt, or you can put like a totally different buffer out here, and then this buffer is going to equilibrate with this, and you'll end up with the same solution in here. If you're doing things with one of these filters, you're pushing out all the salts and the little stuff, but nothing is coming back in because you're doing this in this ultrafiltration way where you're using the force. So what happens is you actually centrifuge this down, this concentrates down, and then you would actually have to resuspend it in the fresh liquid that you want. And you keep doing this in order to push out more of the stuff and then add more, yeah.
So the exact specifications and stuff are going to vary based on what brand you're using. We use these like Amicon ones. This is not like a paid endorsement for them or anything. This is just what our lab uses. So they come in these various sizes, so like 15, 4, and 0.5. With the bigger ones, in these, so they have the membranes on either side. And this membrane is like regenerated cellulose, which is basically just cellulose that they make soluble and then make into a membrane again. And it's made so that they choose this because it like your protein, it shouldn't hopefully stick to the membrane, But you do want to be careful because when you're concentrating, the protein can build up on this membrane. So when you're concentrating, I like to do it in like spurts. So I do like 10 minutes or so. As it gets going, I can kind of see how fast it's going and then alter depending on that. But when you start spinning, so you put your liquid into the bucket, and then when you centrifuge, the force of the centrifuging is going to pull the liquid through, but your protein is going to be stuck if you choose the correct molecular weight. So when the liquid is pulled through, it's going to come out into this outer part, and your protein is going to be kind of like, it's going to be pulled down, but it's not going to make it through. But because it's getting pulled down, you actually can get this like buildup on the membrane, like, and at the bottom. If you were to like look and see, it would be kind of more viscous. And so what I actually do is like after, the reason why I do it in spurts, in addition to just being able to check and see how far it's gone down, I actually like take a pipette and I pipette it up and down so that you prevent the buildup of the proteins from kind of like blocking the membrane from the water and the other stuff that you want to get out. If your protein's like stuck on the side, then like nothing can get through. So we don't want our protein to get through, but we want the other stuff to get through. But if our protein is blocking the way, that other stuff can't get through. So like after every like 15 minutes or so, I push blah, blah. Also, so sometimes when you do this, sometimes you have more volume than it can hold. And so what you can do is you can actually like load more during the thing. You need to be really careful with whatever you do with these guys because this outside part is separate from here. They make ones that like this part comes off in the bottom or whatever. Basically the reason I say this is because typically what you're labeling is like you're labeling the cap and you're labeling the tube. If you label those and now you pull this out and you go to pour off your liquid and you do that with like multiple ones, well now you don't have your name on here. One time I was like, oh, I'll just put the label on this part, but what happened is somehow it like leaked and then it got dye into my protein. Yeah, so be careful. Basically just mark the outside of the tube, but then be careful when you're keeping which keeps with which. So your liquid is going to flow through, and they just have approximate markers for microliters left and that sort of thing. Speaking of microliters left, these have a dead stop, so basically they can't concentrate themselves dry. I think it's like there's like a physical separator, like a physical, like the membrane, when it gets to a certain volume, when it gets to a certain place, the membrane is like stuck, so nothing can get through, not even the water, at just like the very bottom thing. But yeah. So also speaking of when we're getting back to the protein potentially like getting stuck on the membrane, you don't want to leave your protein sitting on the membrane. So when you are done, you want to recover your protein as soon as possible after you're done with it, and don't just like leave it sitting around on here, or you can get protein like permanent. You can like lose protein because it'll get stuck to the membrane, and then like permanently stuck kind of. So you don't want that to happen, so take it out as soon as you can. Speaking of taking it out with these guys, so the way you take it out is going to differ for different things. For these guys it's really simple. You just pipette in and you pipette it out. For some of them you actually have to flip things over. So like with these little guys, what actually you do is that you pour them, you do this flow through and everything, and then you put it in a separate tube and you actually put it upside down, and this way you use the centrifuging to actually like get the force to force the stuff out. So some of them you have to like flip over to get out. With these guys you just like literally just pipette it out. In terms of preparation and storage, so these come with like a little bit of like glycerol or something like on them. So if this interferes with, this is going to interfere with your protein, then you'll want to like pre-wash it. I do anyway. What I do is I just like put some of my buffer in here and let the buffer flow through, just do a few minutes wash, and before I put my protein in it.
You don't want to let it dry out though after you do the wash. You never want to let these like re-dry. So you can actually use these multiple times. We use them single use here. In my undergrad lab, I probably used one like 15 times. I don't know if it lost efficacy. I never really like tested recovery or anything. But I also used ones that were like a decade old. But anyway, that's not probably the best practice. But know that they can sometimes still work. But when you basically, if you store it, you want to make sure that you're storing it wet. So often in some sort of like ethanol solution or water with some like sodium azide or something, so that nothing grows in it. But you always want to keep it wet, never let it dry out. But I mean, like, it comes dry, but then once you wet it, you want to keep it wet. These two centrifuges are different not just because of their size, but because of the type of rotor. So this is what we call a swinging bucket. So you can see these swing, and this is a fixed angle. And this is going to come into play when you're using these concentrators, because they have different fill limits and different like maximum speeds and stuff, depending on the centrifuge type. So you can add more liquid into, if you're using the swinging bucket. So these will hold like if you have a swinging bucket, but only like 3.5 if you are using a fixed rotor. But the fixed rotor can go faster. Typically, you just use what you have. So we use the swinging bucket. And always make sure that you have a balance in your centrifuge. So we just keep like blanks that we use. It doesn't have to be like perfectly balanced or anything. Like, you don't have to like measure out the exact weights or anything. We just use the same blank for most of them. So because the membrane is like on two sides, for some types of centrifuges and some concentrators, you have to be careful, and it tells you like what direction to stick the membrane up, so that the force is going to go the right way, so that things are actually going through the membrane and not through like this plastic barrier, not trying to get through the plastic barrier that they can't get through. So you want the force to be working in your favor. May the force be with you. When the stuff comes through, your protein should not be in here, but if you have not done this before, or like if you haven't purified this protein before or something, if it's close on the limit, basically if you want to figure out if your protein is actually gone through, because that wouldn't be good. But then if you still keep it here, this, instead of just like just dumping it out, you can see if it's actually flown through, but it shouldn't. And make sure that you are doing this with your centrifuge cooled. So often I'm like coming in and concentrating like early in the morning, and so I'm the first person, so you can do like a fast cool down if you need to, but you want to keep your protein cool when you're doing all this, because your protein is really precious. And also another reason, so we talked about, or I don't know if I've talked about it yet in this part, but you don't want to concentrate too far. And so if you concentrate too far, your protein can like crash out, like precipitate, aggregate, all this stuff. Also, if you like, the more you concentrate it, the more you risk losing some. You're gonna lose some, no matter what. But the more you concentrate it, like if a little bit gets stuck on there, you're gonna have a lot more stuck on there if you have like it more concentrated. Plus, when you let go and you like every time you're transferring it, if it's more concentrated, you're going to be losing more, like in all those little drops that are left on the pipette tip and stuff. So you don't want to like over concentrate. But we'll talk later about why concentrate. You do want to at least somewhat concentrate a lot of the time. So a quick note on some of the uses of when you would want to do to concentrate something. And so there are a lot of times when you're doing a protein purification. So with the protein purification, we're often doing multiple steps of protein chromatography, where we're taking our protein through various columns filled with little beads called resin, and they're separating the things based on properties like their charge, or their having a specific tag, or their size. And crucially, the size exclusion chromatography. In these techniques, so like affinity chromatography and ion exchange chromatography, we're actually getting our protein to stick onto the resin, onto those little beads, and then compete it off.
But when we're doing size exclusion, instead of sticking to the beads, the things are just moving through the beads. And so the bigger things are going to travel. They don't have to go through all the little tunnels. The little things have to go through all the little tunnels. So the little things are going to have to travel further than the bigger things. And so the little things are going to, come out later. The bigger things are going to come out earlier. But you're not, when they're going through the column, they just start when they enter the column. They're not sticking and get unsticking. So basically, if you have a big volume and things are really dilute, they're not going to get concentrated on the column. So you need to concentrate them before you get them on the column, so that nothing gets a head start. It's kind of like why we have stacking gel when we run an SDS page. So all the proteins get the same start at the same starting line, and when they're moving through. And so we want to concentrate them down before we then inject them onto the column.
So in size exclusion chromatography, we're going to inject onto one of these columns, but we're going to do it by injecting into this port into one of these sample loops, which is going to store it to us. And so you can see there's like 100 microliters, 500 microliters, 2 mil, we have 1 mil, we have like a 5 mil. And so we need to concentrate it down so that it is a volume that is going to fit into one of those tubes. And so we actually choose, if you want to recover all of your protein, you want to make sure that there's you're actually injecting a volume that's only like a quarter of the tubing length, to make sure that you get everything through. If you care more though about the actual separation, you really want a really sharp peak, then you might lose a little, but you don't need as much. You don't need to leave as much space. And if you're doing an analytical chromatography, then you're going to want to inject more than the loop size, so that you make sure that you have the exact loop volume worth when you're trying to do comparisons.
We also want to concentrate at the very end of a protein purification before we store our proteins. So it's good. Proteins are typically more stable at a somewhat higher concentration. You don't want to concentrate too far, or your protein can actually become unstable and aggregate and precipitate and cause all sorts of problems. So you don't want to concentrate your protein too far. Sometimes how far you can push things depends on the various protein, but you don't want to store your protein too dilute for a couple of reasons. One is that it can be less stable that way. Proteins are used to like a really crowded environment, and if they're not in a crowded environment, they're less happy, and they might kind of misfold a little if they have more room. I like to think of it kind of like they have more room to spread out, and so if they can spread out more, then they spread out more, and then if they're taking up the room, and in a more crowded environment, they're more like stay to your own position. The other thing is that you'll have some protein. You always have some protein that's going to stick onto the tube. And if you have a really dilute solution, now you have a more ratio-wise of the protein you're going to lose more of the protein in a ratio-wise manner than if you had a lot of protein. So it's kind of like losing a drop in a bucket, or like drop in a teaspoon versus a drop in a swimming pool, in terms of how much is actually getting lost. So more concentrated is better for that as well. Finally, if you want to be doing experiments with proteins, typically you don't want to use a ton of volume of the protein when you're doing some sort of like assay, because you want to have room to add all the other stuff you want to add, and you don't want the buffer that your protein is purified in to be like the main buffer that's present in the reaction. So if you add a little bit of protein, then you can have room for lots of other stuff in a set like reaction volume. Whereas if you had to add a lot of protein, now you're not going to have room for all of the other stuff that you wanted to add. So that's not good.